morning. Welcome to session 9, Fueling the Future, how hydrogen contributes to the transport of tomorrow. So just setting the scene, we're now just a few months away from the implementation of European-level laws into European nation-states. In 6 months, in May next year, member states are going to have to transpose, actually are going to have completed transposing European mandates into their own countries. So as that deadline looms, we've got a group of panelists here today to discuss the use of hydrogen technologies in decarbonising transport. As things stand, there's plenty of bottlenecks remaining and infrastructure still needs deployment. So my name's Tim Hard, I'm moderating today. I'm the SVP of Energy Transition at Argus, where I develop the Hydrogen and Future Fuel Service. Our panelists today, it's a wide group from IVECO, from Hypermotive, Fincantieri, a dual hat of Viria Energy and the Belgium Hydrogen Council, and a last-minute addition from FOCO NextGen. So what I'm going to do is I'll just quickly ask for introductions from the panelists. Then we're going to go through some questions with the panel. There is a QR code going to be displayed. So if you have questions, we do have time, fingers crossed, for Q&A at the end. So I'd certainly appreciate questions from the audience for the panelists. The more exciting, the better. So feel free to pose your questions to them. So could you give a quick introduction? Let's just go down the line, just your name, your company, and what you do.
Good morning. My name is Jean-Marc Boucheret from IVECO Bus. We are a manufacturer of buses and coaches. One of our fuel cell buses is over there in the next hall. My role is a sustainable mobility manager, which means that I need to look after the environmental benefits of the different powertrains and look whether they have the appropriate legislative application conditions.
Next. Good morning. I'm Jonathan Brown. I am the strategy director at Hypermotive. Hypermotive are a business that integrate third-party fuel cell systems into a range of applications like trucks and buses and ships.
Good morning. I'm Caterina Cobino from Fincantieri. We are a shipyard. We manufacture ships, and I am a special projects and partnership manager in innovation department and program manager of Wave to the Future, the hydrogen project of Fincantieri.
Good morning, I'm Jeremy Lefebvre, working at the Viria Energy, a family-owned Belgian company, active in renewable energy, active in the production of hydrogen, and I'm responsible for business development for the business unit, hydrogen business unit at Viria Energy.
Good morning, my name is Julian Kellerman. I'm CEO of FOCO NextGen. Thank you for inviting me to this panel this morning. FOCO NextGen is developing a 120-seat hydrogen combustion-powered airliner with entry into service in 2035. And well, it's a collaborative effort, so we will all need all of you in the hydrogen ecosystem to make this work.
Fantastic, thank you. So it's a wide selection of industries being represented, all obviously transport related. So let's get underway with some questions. So Jean-Marc, IVECO to me it's synonymous with heavy-duty vehicles in ICE layouts in Europe. What's your role on, what's your view on the role that hydrogen has to play in public transport sector going forward?
Yes, it has a role in particular because we are going into a decarbonization roadmap. It's been set through the Green Deal and in particularly with the new CO2 regulation that sets high mandates of zero-emission vehicles for 2030. 90% of the city buses that needs to be procured needs to be zero-emission tailpipe. That means that battery electric, fuel cell powered buses have an important role to play. And in particular, when we look at the way the transition is going in terms of visible from the operator, the fuel cell buses have some advantages that we can list. Obviously, they provide a faster refueling, which means that the buses don't stand still to get recharged like you have to do for buses. So the number of hours per day that the bus can be operated is much higher. We've got smarter management of the thermal comfort. We do have heat to dissipate, but fortunately, in a bus, we need to heat and cool the passenger area, which also is demanding a lot of energy, which is, in this case, for batteries, an energy which is taken from the mobility, while with our concept with a blended heat pump, we can leverage on this energy to the passenger comfort. This is very important. Besides, we've got 7 times less batteries. So we use less critical materials. We've got, from our perspective of life cycle analysis as a producer, we've got less of these materials, so we do have an impact. Having said that, we have a lesser weight, so we can carry more passengers. So you can make longer range, fast refueling, better climate control with more passengers and with less carbon impact for the manufacturing. So these are all the elements that speaks in favor of this propulsion solution.
Just wanted to ask, how do you feel about the rollout of fuel cell buses within Europe to date? So, for example, in Brussels, I believe there are 2 refueling stations, but no buses deployed yet. That's my understanding.
We were just speaking about this a few minutes ago together. In fact, yes, the rollout is pretty small. I mean, when we look at the really fast uptake that we have on the other side of our product portfolio, which is the battery electric, and generally speaking about the market, I think it still represents a very small fraction. A few percent of the market compared to the rest. So despite the fact that we've been collectively working a long time and a longer time in the fuel cell, so the willingness is there, the results are not there. We do have a major issue on the TCO, which is, despite all the advantages I mentioned, we do have an issue with the TCO, and we really need to stress that this appetite for the technology can be jeopardized with the issues of TCO, and in particular the cost that comes for the hydrogen as a refueling fuel now. So if we want to reach the 2030 targets, then we should make significant progress now, otherwise some portion of the customers will say, well, I can't make my 2030 targets. I will choose something else. Yeah. It's a real wake-up call for this part of the industry.
Just on the TCO, is a lot of that the upfront costs or the ongoing costs?
We include the upfront cost, we include the fuel, and we include the maintenance and repair of the vehicle. So this is the customer impact of the choices we've made and of the vehicle that we have in his hands during the next 15 years. Yeah. It's not including the driver, it's not including the other CapEx concerns. Mm-hmm.
Okay, so I've been very mean about deployment within Europe so far, but of course there are areas that are having quite fast deployment in Asia, for example. But outside of Europe, do you see challenges for the public transport sector that's trying to decarbonize?
I would say yes, but frankly speaking, being here in this EU Hydrogen Week, so having a focus on this, I mean, we've got these 2030 targets, which is like very important. We consider that there would be other regions where also hydrogen potentially in mass production with interesting geographic benefits could also be interesting. It could be connected to the projects where big sun is there. It could be Africa. I think we all have in mind Saudi Arabia. Could be places where you've got also a lot of wind. It could be Latin America. It could be Australia. So there are regions where we could make a leapfrog from the conventional fossil fuel directly to one of the most sustainable transportation solutions.
Thank you. Okay, well, I could stay on that topic for quite some time, but it's not fair to everyone else. So, Jonathan, your company, staying on road transport here, offers a wide choice of zero-emission technologies to the transportation sector. Are customers in general swamped with choices? Why is it important to have wide choice? What's the role of specifically hydrogen-based solutions?
So I guess we're at a point where, coming from somebody who spent many years designing internal combustion engines, the internal combustion engine was a wonderful tool that did everything very well with a very easy to transport fuel of high energy density, didn't require any special, very limited, very special treatment. So they did everything well. We now have to be far more aware of the energy we're consuming, because all of the energy we're consuming for future mobility is going to come from the general electrical generation grid. And of course there's demands on that growing in all different areas as well. So where we had a singular choice that fitted everything in the past, we really now need to be much more conscious and aware of those decision processes as to how we select the technologies moving forward. It means it's very much more difficult, of course, for the fleet operators and the owners, because they now have to take a myriad of different choices and potentially different options for applications doing relatively similar things, but not necessarily the same. So, bus is an example. You may find that for 90% of your fleet, a battery bus works fine, but actually the 10% of the fleet, it doesn't, and you need a different solution that could be hydrogen. So now you have to manage two different fleets. So it adds a layer of complexity. And what we're trying to do is simplify that as much as possible, because we recognize that it's the people that bear the burden of the cost are those that operate at the end, not necessarily the manufacturers and the OEMs.
We've seen a bit of a stall in terms of battery electric vehicle rollout. A lot of that seems, especially I'm thinking about in the UK, where we've rolled back targets, and I think that's happened in a few other areas as well. Do you see infrastructure constraints playing into the hands of fuel cell electric vehicles? Is that a tailwind, or does it face the same constraints as BEV?
It certainly provides more freedom, and certainly, as you mentioned, within the UK there are grid capacity constraints in terms of moving electricity around the network. Being able to use the energy at different times to create the hydrogen does provide some freedom, and physically you can transport the hydrogen as well, which means you don't necessarily have to be relying on the grid. So yeah, there's certainly freedoms there that can be derived from it.
I think looking at Belgium, I've been very lazy and really picked on Belgium when I was pulling out data. When I was seeing that the car dispensaries, I think there's 5 in Belgium. In terms of FCEV cars, it's 107. So it's not the rollout of dreams in Belgium, and you can make the same point about across Europe. There, places like Korea have done quite well. What's missing from the European impetus towards FCEV vehicles, in your opinion?
I think fundamentally it's about it's driven by consumer choice. If there isn't the infrastructure to fuel them, then why would you have them? It makes life very difficult to run a fuel cell vehicle. But equally, the reality is, and apologies to the automotive companies that we know and love here, fuel cells in private cars doesn't really make a lot of sense, because battery technology has come along so far now. The cost and the complexity of putting a fuel cell into a car like that, unless you're going to do very, very high ranges and require long duties, is very minimal. Really, where you're likely to see hydrogen fuel cells most widely adopted is in the much heavier industrial end of the transport and mobility sectors. So shipping, buses, but heavy trucks, rail, where you are operating off the wires, so North America market, mine areas, things like this. These are where hydrogen makes sense, where you're off-grid for long periods of time. Trying to compete in a market like EVs in public transport, in personal transport, is not really the right market for hydrogen, I think.
Well, okay, what is? So for hydrogen technology, and particularly the case of fuel cells, how do you see the market evolving in the near term, not 2050, in the near term? Where does your company see the best opportunities within transport?
So certainly, as I mentioned, shipping, marine, commercial marine vessels is clearly one area that is showing slow but consistent growth of hydrogen, because there really isn't another option or way forward than using hydrogen in one form or another, so e-methanol or ammonia or LOHC, or even gaseous or liquid hydrogen in marine transport, because you can't take batteries to power a ship across the ocean. And it's that simple. And it's likewise where we're seeing call for it in rail, heavy rail freight that has to move long distances where they don't have overhead electrification, and they're trying to replace diesel engines, and we are working in that area now. And as I say, you're seeing, trucks make sense. Sort of cars don't really so much.
It's interesting that you say that, because one of the things in a Belgian context is that although, as you say, trucks make sense, I think that we are lacking a target in Belgium. Actually, I'll come down the line and ask this in a second, but I'm sure that we're missing a specific target, for fuel cell HGVs. I'll come back on that. You can fill me in. Got to come to you, Caterina. So, your company, Fincantieri, it's a bit of a front runner in the naval industry for hydrogen. Why? Why are you leaning into it? What role do you see for hydrogen as a power source?
Yes, thank you. Yes, I confirm Fincantieri, it's committed, first of all, to energy transition, and also is committed to hydrogen, which is one of the way. This is the reason for which this year Fincantieri is in the book Heroes of Hydrogen, and please have a look. This is one of our shipyard, one of our 18 shipyard, and as you can see here, we have 3 cruise ships under construction. In all this production, we do want to be front runner in, I would say, generally energy transition by using every source that is available. So we do our front runner in methanol. We have a methanol-ready ship. So we are just waiting for the motor. The 4-stroke motor is still not ready, but we are waiting for it. Then the ship is ready. Of course, we are already operating ships with LNG, so when the synthetic LNG will be ready, we are ready for that as well. Ammonia, we also think to nuclear. Of course, all these synthetic fuels, they need hydrogen, so it's enabling of hydrogen market anyway. But let's go to hydrogen. We do have our own project, which is called Wave to the Future, and the project aims to develop technologies for use hydrogen in maritime. These technologies are reciprocating motors, fuel cells. I mean, we don't manufacture fuel cells, but we do develop with our company, Isotta Fraschini Motori, the modules which are suitable and certified for the maritime application. And we also study a combined cycle with gas turbine burning hydrogen. We are integrator of these systems. But then we want to be the demonstrator, integrating the technologies to use hydrogen on board onto ships. We are part of the IPCEI ecosystem, EPCI, the important project of common European interest, and this project is go under this umbrella, and we will finish the project by 2029, so we will see ships using hydrogen on the sea before. Which is the challenge? The challenge, if it can be a power source. The answer is yes, we think so. We are at an advanced stage of design, so we have solved a number of problems up to now. Now we have to build it, so we do have others. Which is the challenge? The challenge is space. We do cruise ships, and hydrogen take a lot of space. both for storage and for the present technology available, which is fuel cell. They are fantastic system, but a very low energy density. It means you need a lot of space. This is the only reason for which we cannot have, for the time being, 100% fueled hydrogen cruise ship.
Is there a future where it's realistic? I mean, would you have to be popping into port every day?
Yeah, in this moment, yeah, but it's really something. I mean, if you can, because we cannot do 100%, but we are speaking about 20 to 40%. And to be very brief, 20 to 40 means we are consistently ahead of the 2035 objective goals of IMO and European Union, because we can, first of all, you save 20 to 40% of the emissions. Then you don't have emission in ports. Then you don't have emissions in protected area. So it's a consistent part. In fact, for Fincantieri, the goals of 2035 will be anticipated to 2025, and the goals of 2050 are anticipated to 2035 when Fincantieri will have the net zero ship.
So can I just understand, in my own mind, is when you're talking about sort of 20 to 40% decarbonisation, is that not on the propulsion side, but more on the internal power side? Obviously, it's very significant for a passenger vehicle.
I have to explain something. Today, the cruise ship produce electric energy with their system, and then they distribute the electric energy to the various points where we need, including the propulsion. Today, you have propulsion with electric motor attached, which are in the sea, and is a very nice system because it allows to save up to 7% of the fuel. So it's an energy efficiency step that we took some 15 years ago. So at the end, you produce the electricity. So how it happens? Part of it is through LNG, part of it is through hydrogen, and then you use as you need it.
What about on the alternative fuels? So obviously looking at this IPCI, and it's an important project, and everyone's watching what's happening with Wave to the Future. I've just come back from Japan and South Korea, where they're looking at the container ships and the bulk ships. And what I've sort of seen from that region is that a lot of people there are not looking at the hydrogen. The ammonia is on pause for now, and the fleets are very much leaning heavily into LNG, with the proviso that in the future, if available, they'll be able to switch to eLNG or synthetic natural gas. Is that a similar thing for operators for existing operators within the cruise ship space? Are they doing similar calculations?
We have to say, operators didn't choose, or better, some of them choose for something. Okay, we have yesterday the example of one cargo operator choosing methanol, and so they have to find the e-methanol around. Some of our operator is on methanol, and for this reason we do have a ship methanol ready. Some other operator want to stay on LNG, waiting for e-LNG being available. Of course, this is I want to say, we have 2 or 3. This is one of the main challenges. If they will not find a sustainable fuel, a green fuel, they will not use it. Okay? So the advantage of LNG and methanol is that at least you can find the gray one, okay? Whilst hydrogen, it's only the green. So you have to find it and to find at a reasonable price. So ammonia, it will be easier probably from a technical point of view, but it's toxic, and on a cruise ship it's difficult to be managed. So in this moment, we cannot take just one way. And also, we have to add that probably to reach our objective in 2050, one way will not be enough. We will have to use many sources.
Yep. It's a really challenging problem in the passenger segment, because I'm trying to think. I mean, if it was for hydrogen, you basically have to have a vessel following you, fueling you, and if you use battery, then obviously you'd have to have a battery-sized ship following you to power you. So it's a very unusual sector.
Batteries is not an option on cruise ship. No, really, we do calculate it. It's impossible from a point of view of the weights.
Yeah.
And so batteries just auxiliaries when you need it, but not for on this kind of ships.
Jeremy, you're very patient, and I apologise on the end as well. It's terrible weight. So Jeremy, I've been picking on Belgium in my stats that I've been putting out. How do you see the business, the hydrogen business, evolving in Belgium? And, well, what are the bottlenecks as well that you can see?
Maybe I will start with explaining what we are doing so that you understand our reality. So at Vir Energy, we produce renewable energy, wind and solar. We produce hydrogen, but we also supply energy to the market, B2B, B2C, natural gas, electricity. And we also supply the mobility market with fuels, the fossil fuels, CNG, recharging stations, and we also supply hydrogen. So we operate today 6 hydrogen refueling stations in Belgium. 5 of them for private cars and 1 of them for heavy duty. When it comes to hydrogen and how we look at it and how we are moving forward, at the side of the production, we took this summer final investment decision for first project here in Belgium in Zeebrugge, in the port of Zeebrugge, for a 25 megawatt electrolyzer, which we are building right now. So if you go by the Belgian Hydrogen Council stand, you will see some pictures of the plant being built right now, which should be operational by the end of 2026. Next to the production of hydrogen, so we operate refueling station hydrogen. We are developing new projects for hydrogen refueling stations focusing on heavy duty, because this is the most relevant in the years to come for hydrogen applications. And when looking at the applications, one of our shareholders is Colruyt Group, which is the #1 food retailer in Belgium, with a very clear roadmap when it comes to decarbonization of logistic operations. So we serve Colruyt Group in its ambition to decarbonize by 2030 and 2035 the logistic operations. We have been talking about electrification and hydrogen. Let's be very clear, we don't think hydrogen should be the main solution for logistic applications, so we made a cut with Colruyt Group, and how we look at it is about 1/4 of the operations should be on hydrogen, and then the rest should be on battery electric. So we are not looking at the very big market, we are looking at the niche where it's relevant. So basically, we will have the molecules by at the end of 2026. We will have the refueling stations because we are working on it. What we are struggling with now, and the following challenge, is having the trucks. We have been speaking about the technology that would be available. Now we are looking for the trucks that would be available by 2027, 2028. And that's kind of not always easy to have a clear view on what will be available, what will be the technology be doing by then. But that's what we are currently working on with Colruyt Group and other initiatives.
Are there any other sort of bottlenecks that you're seeing at a national level, other than that you've mentioned? Because obviously you talked initially about some of the rollout and how that's actually happening. Are there any obvious things in the way for a better deployment within a Belgian context? Obviously, you mentioned some of the things. I mean, we've done some hydrogen studies on Belgium. You look at it as a location for bunkering. You know, for example, in the HGV sector, looking at putting refueling stations outside of town centres, and this is all very sensible. But is there any single issue that stands out to you as a problem at the moment?
Issues, finding issues or challenges is not the problem with hydrogen. It's very complex, obviously. Everyone is much interested into hydrogen. When you speak about hydrogen, a lot of questions, not always answers available. So the number of challenges is high. I mean, one obvious is regulation. We haven't been speaking about it, but RFNBO regulation, for example, is one of them. Also, clear targets for the industry, for the manufacturers of vehicles is one of it, but also the translation at national level. And because you can have a European regulation that is not translated on time or in a different way in your own country. So that's also something that we are closely following up, but that we do not have in our own hands. Our DNA or philosophy is more that we are trying to look very pragmatically at challenges and finding very concrete solutions on the short term. So one of the way we are tackling that is together with the Belgian Hydrogen Council. There is currently an initiative where we try to build what we call minimum viable ecosystems. So basically, we used to speak about the chicken of the egg problem. It's an easy image to use, but actually it's more complex than that. You need more than just a truck or a filling station. You need molecules, you need a refilling station, you need trucks, but you also need companies to buy the trucks and to operate the trucks, and those companies need also customer willing to pay the premium price. So we like to look at it as a minimum viable ecosystem and not as a chicken of the egg. And that's why there is an initiative that we are supporting with the Belgian Hydrogen Council, where we try to move on all those topics with all the stakeholders involved in the supply chain. So what we contribute, or what we try to create as Vira Energy to that challenge, is to create visibility on the future, and I speak about the near future, 2027, 2028, about building refilling stations, and also about a price that we want to reach at the nozzle. And the target price that we have, and what we are working very hard every day, is to be able to offer hydrogen at 10 euros per kilogram at the nozzle, so that it gives also visibility on TCO for the potential customers.
So I was going to ask, earlier I mentioned, I don't think in Belgian policy there's a target for fuel cell HGVs. Is that correct or incorrect?
There is no targets, as far as I know, regarding technologies. What there is the European targets regarding the part of RFNBO you should have in mobility, but then mobility in a broad sense, it can be shipping, aviation, or mobility. And so that is typically what we are now missing, very clear targets at Belgian level on how should be the targets for each of the segments, for each of the labels that have been put by the European regulations.
I suppose I'm more interested in mandates than targets. The hydrogen industry is replete with targets, and they are going to be missed in a lot of cases. So I'm always keen on mandates, because it's something concrete that you can point to, and it's actually going to stimulate demand.
Yeah, I think...
And it kind of plays into what you're talking about with a minimum viable ecosystem, because if there is an actual quantified number on the roads, then you can say what the demand is going to be for fuel, for etc., for imports or production, and you can also see what the need is for refueling stations and mechanics and things like this. So, what do you think about that? Too far?
I think the targets are important to give to put a framework and to give a signal and give direction. But the target is also easy to say in a few years' time. Okay, we'll just adapt the target, or we'll just postpone the target. So I think it's important to give the direction, to also give the incentive to the local public, and to give the support also to the people trying to move forward. Again, what we try to do is starting from our project and looking at what do we need for our project, and project is not only our company, but what do we need at Belgian level to create an ecosystem that will be a good leverage to start that economy of the hydrogen. So targets, yes, it's important, symbolic, but I'm not so attached to targets as such. I think it's much more important to have a clear direction and also to stick to the direction.
Yes. So from a Belgian Hydrogen Council perspective, how can we work to increase hydrogen demand here? And is that something that can be applied in Europe? Because traction's struggling.
Yeah, so I was explaining about one of the initiatives is with the heavy-duty trucks, what we are currently busy with, and busy with, I mean, next week we'll have another meeting to move forward. And there again, the approach is not... It takes also some time, because there was a lot of buzz again in 2020 when announcing very big targets regarding hydrogen in Europe. But then now it seems that there is more reality and realistic sense in the ambitions for hydrogen. So it also took us some time to identify the stakeholders that are willing to engage and willing to move forward. And that's what we have reached now, I think, at this stage, and also thanks to the Belgian Hydrogen Council efforts to really identify the one willing to move forward, so that you can have concrete plans and concrete discussions, because you also need confidence between each others, so that you can move forward and not alone, because we need each other.
Fantastic. So lots there on the road, on the water, and now to the air, and to the most patient man on this panel. So thank you for waiting for me to get down to you. So, Julian, I was going to ask, what hydrogen-based solutions would be best suited to regional airline needs? So obviously, I'm interested in this, a big aviation family, and I've been very interested in what's been happening with the mandates from a structural level within Europe recently. So, you know, what are the regional airlines going to use, and what share of operations could actually run on hydrogen in the medium term, I suppose?
Well, thank you for your question. Intra-European market, there's of course not one solution for this. So, and I think also, judging from discussion before here, that larger transport vehicles could benefit from hydrogen. For instance, fuel cell powered aircraft will be come on the market by the end of this decade. Primarily, there will be modified existing aircraft, and by the middle of the next decade, new aircraft like ours, or Airbus is also working on one, will come to the market. But let's not forget that there's an existing market of aircraft, conventionally powered. They will have to switch from fossil fuels to SAF. I can be very ambitious, but let's be honest, the incumbents are producing about 50 to 70 aircraft per month for the next 10 years. So we need to clean them up as well. So in that sense, SAF, power to liquid or power to X, will be very important, and hydrogen can play a role in that as well. Then lastly, also for the extremely short range or short range, battery-powered smaller aircraft could play a role for the regional market. But in general, we see a great role for hydrogen-powered aircraft in the range between 80 and 150 seats. It should be possible. The larger aircraft will be powered by hydrogen combustion, because we see that for decades to come, that will be the only way to have CO2-free emission aircraft in the air for larger aircraft going a long distance.
So when you say that, you mean straight hydrogen, not e-kerosene?
Correct. Because well, you all know more about hydrogen than I do. So in that sense, when you combat the volume issue and also some of the shifting point of gravity issues, then actually it could very well be one of the main sources of energy in aviation. We all know that we will need a molecule to carry the energy. Electrons will not do it for larger vessels or aircraft in that sense. And if you add things up, and well, 6 years ago when we started with this, everyone said it's crazy. But if you look at also here, Hydrogen Week, it's growing and growing. So it could very well be a solution. And if you look at what also in ASEA has been talking about, it could be anywhere to 30 to 70% of the regional market that will fly on hydrogen in some form.
Yeah, it's interesting. You talked about the SAF side having to step up and take decarbonisation of the existing fleet more, and there is a lot of capacity that's come online and is still coming online. There's probably a finite limit to how much can be brought on there.
Also circling back to the conversation you had with my neighbor here, that even mandates in place or rules or regulations and everything else that is being done for SAF, I still hear a few potential and current SAF producers complaining about that it's still difficult to get funding or public funding for their project. So a mandate per se is not the silver bullet to get the things going. I believe in the end, and we all agree that we need to make this economical viable. Yes, we need help for the transition, but afterwards it needs to pay for itself, and we need to show our end customers that it can actually be economical. It can be cheaper than current fuels.
There's been a lot of people running into eSAF recently, and quite a few companies have put it out as being one of the most profitable segments, potentially, within the hydrogen sector. So, from the producer point of view, which should incentivize a lot of production if that's the most profitable area. But do your customers, how do they feel about supply coming online, the likelihood of supply being there? Because that's fundamental, obviously, to anything actually running on hydrogen. So is there something particularly from the aviation sector that you could share?
It is a subject that is being discussed. It's very hard to look into the future. Also, if you look at the innovations, it's not a straight line. Usually it's a hockey stick. So I'm not worried that the developments are now less than we expected to be, because I see that it will ramp up when it's needed. So in that sense, I'm not worried. There's also, of course, the question, will there be enough hydrogen available for transport use? Because maybe heavy industries will use it all. But you also hear talks, particularly in Europe, that we might need to save some of the hydrogen for the hard-to-abate sectors like transport, because other heavy industry could eventually also move over to electricity. So first of all, also the question that is not being asked in this panel is, of course, we first need sufficient supply of green energy in Europe and to be self-sufficient in that. I think that's the main question. If we have that, then we can make a choice what we do with that energy and make SAF or hydrogen or whatever we want.
Yeah, and the biofuel segment's actually been growing very, very quickly over the last decade. And that's actually another potential source of demand for clean hydrogen rather than the grey for hydrogenation. But from the ASEA vision...
Sorry to interrupt.
Sorry, go on.
For our aircraft, it's a hydrogen combustion. So it will fly on any color hydrogen. And also we don't need the purest form of hydrogen, because it will also burn on 80% or whatever. So our aircraft will also be able to fly on SAF or kerosene, so that will help in the period of market introduction. So in that sense, it's very versatile. And there's also a lot of talk about the transition. That won't happen in one day. So we will have time. The first products in the aviation industry will come online at the end of this decade, more halfway through, but also for us or any other, it will take time to ramp up production. So there will only be a number of aircraft by 2040 in that sense. Yeah. So we will have time to together grow this ecosystem and also discuss with the different value chains of airports, of airlines, of fuel suppliers, how we can ramp this up. And I agree to be in a panel, but I'm an engineer from origin, so I like to do things. So I also encourage others, and also in ASEA, to stop talking about this, but take the first step and let us show the world that it can be done.
Well, from ASEA, are there stumbling blocks that you see, obvious ones for deploying H2 in aviation, especially regional airports? Because I think that's an interesting topic, because obviously the large national hubs are very different from the regional ones, and they're supplying different routes, different distances, those kinds of things. So can regional airports also be made into local hydrogen hubs?
Yeah, well, any transition, of course, offers also potential new business models. For existing business models, maybe that's not something they want to hear, but it could very well be that smaller regional airports could be their own energy supplier. Because why should the incumbent energy supply or fuel suppliers be the ones that do it? They could also provide hydrogen to aircraft or the buses that are coming there, or cars, or whatever. So we see that happening already. We are in discussion and also in projects all over Europe to help them make this transition. But of course, there are some challenges in doing that. Coming from the aviation industry, safety is paramount. So we look at safety first. Of course, we need some infrastructure in place, and it needs to be it needs to be scalable. So otherwise, well, for instance, if you would plant a small electrolyzer on an airport, but then the bigger ones come online in a radius of 60 kilometers, then it would not be economical viable to have this small electrolyzer on an airport. So you need to have a broader scope in that sense as well. So I see for the main hubs, they also potentially have a connection to the gas pipeline system, which will be converted to hydrogen. For smaller airports, we can start with just fueling trucks. Our aircraft will carry about 2,000 kilos of hydrogen that can be carried in a tank as well. So we can grow in this. But I believe, and this is also part why we're here and talking to governments and Europe as well, we need to communicate about this. We need to communicate about the differences in hydrogen, also for the regional airports. It's not more dangerous than kerosene. It has different properties, but it's not more dangerous. And also, altogether here, the transport over the last 100 years have been, although the margins are slim, we have been one of the most innovative industries in the world. And we will keep doing that for the next 100 years. We should be proud of that. And we should also convey that to the general public, which will help also persuade politicians to work with us in this sense.
Fantastic, thank you. So just as you were talking about, let's move to the Q&A. So please send in any questions that you have. You were just talking about direct combustion of hydrogen in aviation. I can see there's a question up here. Europe has a long history in terms of engine development and production. Transposing that to the road sector, on the road, is there any opinions on retrofitting ICE to run on hydrogen rather than fuel cells? From anyone?
I could complete on this. IVECO Group is manufacturer of trucks, buses and coaches, but we are also our own manufacturers of powertrains. In the powertrains, obviously diesel is famous, but we are also the European leader in natural gas. And internal combustion engine hydrogen is something we are considering. Now that we know since this summer what is Euro 7, we know that according to the CO2 regulation, and hydrogen ICE can be recognized as a zero-emission powertrain. So we have a different range of engines that are likely to be converted. We introduced the 13-liter in the Hanover show IIA. We also disclosed a prototype of a 9-liter, which is also a candidate for our coaches. I wouldn't dedicate this for buses because we have so much interest by energy recuperation with an electric powertrain, because you have the possibility to store your braking capabilities in the batteries. But in a regional coach, why not? And our job now is to look at how to make it economically interesting in terms of both costs and also fuel consumption. So this is the jobs that we have to carry on, because today the buses in particular is the most advanced and a front runner in terms of alternative propulsion. More or less today, half of the buses which are sold in Europe are already non-diesel. And as IVECO bus, we represent nearly 1/3 of these sales. So we are looking at all options. We are leader for gas and biomethane. We also have solutions for HVO and biodiesel, battery electric, and as we say, the fuel cell hydrogen, and looking at potential hydrogen eyes. So that today we have to be quite clear. The market conditions, the enabling conditions are not there to reach the 50% we have now up to the 100% we need by 2030. The reality check of the market is that if the fundings which were available for the municipalities which were coming from the resilience and recovery facility is expiring in 26, then what happens? And we already have signals that the market is not stopping buying buses, but could stop buying fuel cell buses or battery-powered buses. So again, it's another wake-up call that if at EU level we don't come back with the appropriate measures for CapEx of the conversion of the acquisition of the vehicle and the infrastructure transformation, transforming a bus depot that is in a city is a tricky story. You need to bring the power, you need to have the safety issues solved. This is the only way to go. So please, let's be with this new European mandate starting now, let's get things done.
Thank you. Katerina, I have a question for you, which is, will there be a preferred fuel in the future, whether ammonia, methanol, LNG, or is there space for all solutions? I want to add a second question to that, which is, would that make, if there's many solutions, does that make the sector as a whole, and I mean maritime movement, more or less resilient than, because the existing markets today are quite monolithic in terms of fuel?
Okay, I just wanted to come back to the ICE question. And then I will answer to this as well, which has been already taken before. But anyway, for the maritime sector, yes, ICE motor, I think, is the solution, because it has two characteristics in respect to fuel cell. The first one is energy density, which is very consistently better, and it allows to do 100%. And the other thing is today the fuel cells are incredibly expensive to a non-sustainable. So only the fund can sustain this. Going back to your question, yesterday we had an high-level conference with the Port of Rotterdam, and it was a surprise to me to discover that they don't consider a criticality to manage many fuels. They said we already do it. So to me, it was a criticality, but yesterday I positively discovered that is not. So in terms of resilience, I mean, it's a difficult question, but I think that to have different solutions with this position of Port of Rotterdam, I think that will help the resiliency, and it will help it consistently, because we have learned very recently that you have just one source, just one supplier. It's the worst thing that we can do.
Good stuff. Jeremy, I wanted to come back on something you said earlier. You mentioned you'd taken FID on a 25 megawatt project. From memory, Belgium has a relatively low target, I believe. I think it's 150 megawatts by 2026. Is that right? Whether it is or not, but actually no. Is that correct? Is it 150 megawatts for the country by 26?
I'm not sure that our targets have been defined by Belgium. The Belgian strategy is basically looking more at its role about connecting Belgium with other countries. We are, because of geography and history, a very, we have Zeebrugge, we have other, we are an energy hub where a lot of gas and energy is transitioning. So the main focus is on building those infrastructure at the ports or the gas pipelines that are needed. So how we look at it is, you need local production anyway just to start doing. I agree with the fact that you can speak a lot about targets and then what should be the ideal solution on paper. But the reality is we need concrete projects to move forward and to learn from it. And that's how we look at it, and that's why we decided to invest in that project, because it allows us to have the first molecules, to have the first refilling stations, to have the first trucks, cars, buses anyway. And then we'll see on the longer run what would be the solution, how can we import, would it be ammonia, would it be methanol, from which country it can come. But we believe that local production at a certain range makes sense now today.
Thank you. I was going to ask one more thing, actually, which is that I think Antwerp was targeting something like 10 million tons a year of green ammonia imports by 2030. And I know it's a target. How infeasible does that look at this point?
It's difficult to assess. I mean, we are in hydrogen, and managing a 25 megawatt project is already very complex. Managing a refilling station project is very complex, and finding the trucks is also complex. So when I look at and I hear and we follow up closely on, it's very interesting and very promising. Production of green ammonia in big volumes in sunny countries, in southern countries. But it seems complex to me. And again, I think it's feasible. I hope it's feasible. But on the short term, it's difficult to imagine that such project can take FID in the coming months, so that we could have the first molecules by 2026, 2027. So I hope it's feasible, but I didn't do the maths myself, so I cannot assess that target.
I shouldn't do it, but there was a nice question at the end, which is, what are the potential synergies between your respective sectors, and how can your industries, so road, aviation, marine, is there any way to cooperate to speed up deployment? So very quickly, because we are out of time, but let's rapid fire, please.
I'll jump in and very briefly, it's collaborate. Historically, it's almost been impossible. I used to design internal combustion engines, and we couldn't get collaboration between different sectors on standards then, but that is the way forward. It is tough and difficult and expensive and time-consuming to develop this new technology. Having a range of different standards for each different sector that you're going into is killing technology developers. And that's the critical thing. We're working on technologies that cross those sectorial boundaries to help speed up integration. But it's really difficult. And whether you're working bus or aerospace, or there are some things that have to be different. We recognise that, but there's a lot of things that don't have to be different, but are, just because we've never had that level of collaboration.
Julian, did you want to come in?
Yeah, sure. It's a mostly faceted question, but short answer is we're developing new large products. The logistics will be complex. Large parts will be traveled all over the world, so we need also to demonstrate less CO2 production in our product. So I hope there will be CO2-free ships to be able to carry this. And also we need the last mile solution. So therefore fuel cell-based trucks would help do this. The other way around, our aircraft needs a lot of electrical power. So a fuel cell bus size would help as a fuel energy source on board. And also, if you look at shipping, most combat ships use gas turbine engines, so they could be converted to hydrogen as well. So I do see a lot of links between our different sectors.
Final word, if you keep it punchy.
Yeah, the synergies for me is really looking at the geography with local hubs about production energy of hydrogen with local consumers. So we as bus, we can provide a very strong localized fleet. Then you could have garbage collection truck. You could have nearby the food market where also a lot of trucks are coming on. You could have, fortunately, near these big metropoles, some petrochemical industry. So hopefully all the producers and consumers would be very close, so you would reduce some of the burdens of the transport of hydrogen. At least when we look at the ADEME call for projects from France, they have been called the ecosystems, which means that production and distribution consumption is the same spot. So, and it also could be close to the port, where you've got another place where a consumer is massive. So these are really The only chance is on these concentrated geographic hubs, production and consumption.
Fantastic. Well, look, thank you all very much for joining us today. Time is up. Please do stay around and doorstep these guys as they leave the stage, and please join me in giving them a round of applause. They've been a really good panel. Thank you.